A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
For centuries, the eerie songs of whales have echoed through the oceans, haunting, mysterious, and full of wonder. Sailors, explorers, and scientists all listened in awe, amazed by these majestic giants who spoke in voices we could hear but never truly understand. That is, until now. In 2025, scientists used powerful artificial intelligence to finally crack the code of whale communication. What they discovered wasn't just sound, it was intelligence, structure, and meaning. Something far more profound than anyone expected. Something that forces us to rethink what we know about language, consciousness, and even life itself. This breakthrough could completely change how humanity views the ocean's greatest giants and our own place in the natural world. So let me ask you this. What if I told you scientists have just decoded the language of whales with AI? And no, it's not just about cute calls or playful splashes. What they found may rewrite everything we thought we knew about intelligence on Earth, because whales aren't just singing, they're responding. Orcas aren't just hunting, they're organizing. And some researchers now believe we've been missing their warnings for years. Even mainstream voices, like Tucker Carlson, took notice when this discovery surfaced in scientific circles. The ocean has been speaking all along, and now, for the very first time, we're speaking back. But here's the part no one expected, what the whales might actually be saying. Beneath the waves, there's a hidden code, and it begins with a single click. Not the kind you'd think, not from a keyboard, not from a camera, but from deep within the ocean, an echo bouncing off coral walls, drifting through miles of open water. For decades, marine biologists have been listening to these strange clicks, known as kodas, produced by sperm whales, the massive, deep-diving mammals with brains larger than any other creature on Earth. And here's the thing. Those clicks weren't random. They were rhythmic, deliberate, repeated with an almost eerie precision. But the question that haunted researchers was always the same. Is this really a language, or just noise? For years, scientists suspected there was more meaning hidden in those sounds than we realized. Some kodas seemed to act like names, personal signatures identifying individual whales. Others appeared tied to context or emotion, greetings when pods reunited, or urgent cries when calves called out to their mothers. And yet, despite decades of study, no one could truly explain the grammar or vocabulary beneath the clicks. The tools just weren't good enough. Most research relied on human ears, painstaking spectrograms, and endless guesswork. It was like trying to crack Morse code in a foreign language without ever seeing the key. Then, everything changed. In just the past few years, the field of marine bioacoustics collided with another discipline entirely: artificial intelligence, and the results have been nothing short of staggering. One of the most ambitious efforts leading this breakthrough is known as Project CETY, short for the Cetacean Translation Initiative, based in the Caribbean. This project brings together an incredible team of experts in linguistics, artificial intelligence, marine biology, robotics, and even cryptography. Their mission is as bold as it is historic: to decode the language of sperm whales, and maybe, for the first time in history, speak back to them. The whales they focus on live in the waters near Dominica. And there's a reason for that. This region is home to stable, multi-generational whale families. That means researchers can track individual whales, observe their social bonds, and study their unique vocal signatures across years, even decades. To capture all of this, scientists use powerful underwater microphones called hydrophones, along with specialized tagging equipment. The result? One of the largest and most detailed collections of sperm whale sounds in existence, over 50,000 hours of recordings, and still growing. But raw data alone wasn't enough. The real breakthrough came when researchers began applying advanced machine learning models to the recordings. These weren't ordinary algorithms. They were built on the same transformer architecture that powers today's most sophisticated language models, the kind we use to process human speech and text. When trained on whale vocalizations, these systems started detecting patterns, layers of structure hidden deep within the clicks. Researchers found recurring elements in timing, pitch, rhythm, and spacing. They repeated within family pods and even varied between clans. The whales weren't just making sounds. They were using what some scientists now believe are the building blocks of a complex language. Some of the early findings revealed something eerily familiar. Dialects. Whales from one region produce slightly different kodas than whales from another, and these variations persist across generations. Young whales spend over a decade learning their family's patterns, mimicking them the same way children learn to speak. And when males leave their birth pod to join another, they often adapt to the new group's dialect, shifting their clicks to match. That kind of flexibility isn't instinct, it's cultural learning. And yet, scientists say this is still only scratching the surface. For the team behind Project CET1, every new data point strengthens one profound possibility: that sperm whales have been speaking in a structured, meaningful way for millions of years, and only now do we finally have the tools to begin understanding them. If that's true, it doesn't just change how we see whales, it changes how we think about intelligence itself. These giants were communicating across oceans long before we built cities or carved symbols into stone. The conversation was always there. The silence was ours. This was the breakthrough no one was truly ready for. For most of modern science, decoding animal communication had always been a slow, painstaking grind. A few vocalizations, years of behavioral observation, and maybe, just maybe, a hypothesis about what a single sound might mean. Take researchers like Jacqueline Aubin, who spent years studying beluga whale calls in Canada. Hundreds of hours listening to one sound at a time, searching for patterns by hand. No grammar guides, no translation dictionaries, no shortcuts, just persistence and patience. Then, artificial intelligence entered the picture. When Project CET brought machine learning into whale research, it wasn't just about speeding up data processing. It was about uncovering hidden structure in a language no human had ever spoken. The models, built on transformer architecture, the same technology behind cutting-edge human language translators, were now being trained on whale kodas. What once would have taken decades could now be mapped in weeks. Entire lifetimes of recordings could be digested, categorized, and compared in a fraction of the time. And then came the surprise. When the AI analyzed 8,719 sperm whale vocalizations, researchers expected chaos, just noise. Instead, patterns began to emerge. The whales weren't simply repeating sounds. They were building them using consistent components. The AI detected 4 key elements across the kodas: rhythm, tempo, rubato, and ornamentation. Rhythm, the spacing between individual clicks. Some kodas were evenly spaced, while others varied with bursts or long pauses. These shifts seemed to map onto urgency. Fast clicks appeared in social or reunion contexts, while slower ones showed up in what scientists called deep conversation. Tempo, the overall speed of the sequence. Some lasted just over a second, others stretched to 5. And those longer patterns weren't random. They followed internal rules, hinting at hierarchy and complexity. Rubato, a term borrowed from music, subtle shifts in timing that expressed emotion. Just as humans might speed up when excited or slow down when serious, whales seemed to color their speech with emotional nuance. Ornamentation, extra clicks or flourishes at the end of patterns. These weren't mistakes. They appeared in specific contexts, like mother-calf reunions, suggesting they added emphasis or emotional weight, much like tone in human language. When researchers tracked these elements across families, the story became even more intriguing. Each whale group had its own version of common kodas. Variations in rhythm or ornamentation consistently appeared within pods, but not in others. These were dialects. And the data showed young whales spending more than a decade learning these dialects from their elders. Even more astonishing, some adult males, after migrating to new pods, adapted their vocal style to match the new group's dialect. This wasn't instinct. This was cultural learning. Scientists were stunned. This kind of vocal flexibility suggests something remarkable: a deep awareness of social context and the ability to change behavior to fit it. In human terms, it's like deliberately learning a new accent just to blend in. Not instinct, adaptation. The AI wasn't just showing researchers how whales speak. It was revealing that whales might actually choose how they speak, depending on who they're with. And that was the moment many scientists realized they were looking at more than just advanced communication. To some, it pointed to something bigger, a form of cultural intelligence, a system of inherited knowledge passed down not through writing, but through sound. For Project CET1, this didn't solve every mystery, but it shattered one illusion, that humans are the only species capable of shaping and evolving language across generations. Because if whales have dialects, grammar, and emotion in their speech, then the next question becomes impossible to ignore. What are they actually saying? And are they ready for us to finally understand it? It's one thing to listen, to catalog clicks and rhythms, to map out syntax, to piece together the grammar of an ancient language echoing across the sea. But Project CET, I was never built just to listen. The real test, the one that kept researchers awake at night, was this. Could we respond? Not mimic. Not just play back old recordings, but actually generate new whale vocalizations based on their grammar, sounds no whale had ever made before. Would the whales understand? Would they even care? According to the team, this was a turning point. After analyzing thousands of kodas, the AI had learned the patterns well enough to start producing its own. Using models trained on timing, rhythm, and emotional cadence, the system could now construct entirely synthetic kodas. These followed the rules of sperm whale communication, but didn't copy any real whale's voice. They were, in effect, original sentences, created by a machine, for another species. Naturally, the scientists hesitated. They knew they were crossing a boundary. This was no longer passive observation. This was the first attempt at active interspecies communication, using a language we didn't fully understand. But the potential payoff was too great. If whales accepted these AI-generated kodas as legitimate signals, it would prove the structure of their language had been at least partially cracked. So the team prepared a test. In a quiet stretch of ocean near Dominica, researchers positioned their vessel close to a pod of sperm whales that had already been acoustically tagged and studied. Submerged speakers were lowered into the water. Then, carefully designed kodas were played, reunion calls, greeting sequences, social engagement patterns. Each one matched the dialect of that specific pod. And then, they waited. The results stunned even the most cautious members of the team. In preliminary trials, 68% of the time, the whales responded. When the AI played a reunion call, mothers and calves physically approached the vessel. When the AI played a greeting coda, the pod paused. Then, almost deliberately, they responded with returning kodas of their own. In some cases, they lingered around the vessel longer than usual, as if curious about what had just happened. Some scientists believe this wasn't just recognition of sound, but recognition of intention. Of course, it's impossible to know whether the whales believed another whale was speaking, or whether they simply identified a familiar structure in the signals. But the consistency of their response suggested it was more than coincidence, and it wasn't just one pod. Multiple families displayed the same behavior. The AI wasn't only generating grammatically correct whale speech, it was producing vocalizations that whales treated as meaningful. It was as if a door had creaked open. For the first time in history, humans had spoken to whales in their own language, and the whales had answered. But it didn't stop there. In the days following the playback experiments, researchers kept monitoring the tagged whales. They noticed subtle but intriguing changes, shifts in pacing, slight alterations in ornamentation, and even what seemed to be echoed kodas, patterns resembling the very ones played from the boat. Some scientists believe this could represent a primitive form of back-and-forth exchange. Others urge caution, suggesting it might be coincidence. Either way, something had changed. Still, the possibility that the whales weren't just responding but actually engaging left the team speechless. This wasn't a parlor trick. It wasn't a publicity stunt. It was a carefully controlled scientific experiment, and it had worked. According to the Project CET team, the implications are staggering. For the first time, we are no longer outsiders with microphones, eavesdropping on an alien conversation. We are participants. For generations, humanity believed we were the only species on Earth capable of true language. That assumption has now been shattered. The AI didn't just crack the code, it spoke. And against all odds, the whales chose to listen. At first, everyone was focused on the breakthrough itself, the fact that AI-generated kodas had received genuine responses from living whales. That alone felt like a monumental leap for science. But as researchers continued feeding more and more data into the model, something unexpected happened. The AI began surfacing patterns no one had noticed before, and those patterns raised a whole new set of questions. Questions that could change everything we thought we knew, not just about whales, but about intelligence itself. If we were starting to understand how whales communicate, the next question was obvious. What are they actually saying? The AI had already mapped the structure of kodas, rhythm, tempo, ornamentation, but now researchers looked at context. They compared calls near boats, fishing zones, and shipping lanes with those in quiet, undisturbed waters. The results were subtle, but consistent. Certain vocal patterns appeared far more often in areas filled with human noise. One stood out, a string of rapid, rhythmically complex kodas, usually repeated 3 times, followed by a long pause. These weren't used for feeding or bonding. They showed up almost exclusively near active ship routes. Some believe this could be a warning signal, or even a boundary marker. The whales weren't just talking to each other, they were responding to us. And then the twist. When the AI cross-referenced whale movement data, it found the same vocalization spreading across pods that had never interacted before, almost like a shared alert system. If true, it means whales may not only learn within families, but across groups, passing information through a distributed language network, a kind of whale diplomacy. The Project CD team is cautious, but behind the scenes, one phrase keeps surfacing. This changes everything. Because this isn't just noise near ships. It may be the first evidence of whales adapting their language to respond to modern threats. We thought we'd find a few symbolic sounds or emotional cues. Instead, we may be uncovering something far more unsettling, signs of agency. Whales may not just be talking to each other. They may be using language to set boundaries, to say, this space belongs to us. Some scientists now warn that human noise, sonar, drilling, shipping, could be disrupting these boundary signals, interfering with a system we barely understand. If we've already missed their warnings, what else have we overlooked? The truth is unsettling. This might not be a conversation of welcome, but of negotiation. And if that's true, it's not just a scientific breakthrough, it's a moral reckoning. We're no longer the only voice in the ocean. And while sperm whales reveal the structure of an ancient organized language, another species is making headlines for a different kind of message. Off the coasts of Spain and Portugal, orcas have begun systematically attacking boats, and researchers say this behavior isn't just spreading, it's evolving. The first reports came in 2020, young orcas bumping sailboats in the Strait of Gibraltar. At first, scientists dismissed it as curiosity, maybe sparked by the quiet seas of the pandemic. But instead of fading, the behavior grew. By 2024, more than 670 incidents had been recorded. 4 boats completely sunk, and nearly all of them trace back to just 2 family pods. The pattern points to one female, White Gladys, believed to have started it after a traumatic encounter with a vessel. Others copied her, turning resistance into learned behavior. What's even more chilling is the communication. Orcas use long-distance whistles to gather, synchronized buzzing during the attack, and coordinated calls once a rudder is destroyed. For researchers, the realization is clear. This isn't random aggression. It looks like strategy. These orcas aren't just copying a trick. They may be building a new acoustic system around it. Some researchers call it a real-time cultural cascade. Vocal analysis suggests the calls during rudder attacks are unlike any other known orca sounds, meaning they could be encoding and spreading new knowledge. That's what makes the contrast with sperm whales so striking. Whales preserve an ancient, stable language. Kodas pass down slowly, generation after generation. Orcas, on the other hand, are adapting fast, inventing new behaviors and possibly new forms of expression in just a few years. Sperm whales preserve an ancient, stable language, while orcas adapt quickly, shaping calls to fit identity, hunting, or conflict. The Iberian boat attacks began as a possible trauma response, but spread like a cultural meme, raising the question, is this strategy, warning, or even a new dialect. For the first time, AI is helping us glimpse whale language, patterns built on rhythm, tempo, and intent. Researchers hope to map grammar, identify words, and move from translation to real dialogue by 2027. But this breakthrough forces new questions. If whales can tell us what they need, do we have a duty to listen? Some believe orcas are already sending a message through their attacks, a form of protest we can't ignore. These findings suggest the ocean is full of voices, not silence. We're no longer just studying animals. We may be negotiating with them,